The marking of EX equipment is too difficult to understand. I feel I need a deciphering code just to understand what I'm looking at. Is there an easy way to remember what I need to know? Yes, there is. Hello and welcome back to the Explosion Protection Professional EXPP Micro-Learning Series. I'm Bob Johnson, your learning facilitator and guide through the world of explosion protection. In our last video, you learned how T-codes are an essential consideration when selecting EX equipment, an important aspect that cannot be overlooked. Today, we'll review a few sample marking strings typical of EX equipment and remove the confusion on understanding the basics of hazardous location marking equipment. Understanding the marking of EX equipment is truly fundamental in understanding explosion protection. If we don't know the basics, we cannot truly become competent in the world of EX protection. This video will give you an understanding that all equipment manufacturers must follow regardless of what market the equipment will be used in and is suitable for. The details of what is required in the marking string and how to put these together are spelled out within the IEC 60079-0 standard general requirements, and more detailed examples are provided within the standard for further review. The first part is the two letters EX. This is the universal designation that the equipment is explosion protected. The second part is the protection concept or concepts. In this first example, this equipment is flame-proof, so our designation is the small letter DB. You may be familiar with the legacy marking of just a small d. However, changes to the standard now require the addition of a small A, B, or C behind the protection concept to designate what zone the equipment is suitable for. In this case, DB tells us that it's a flame-proof and it is suitable for Zone 1 and Zone 2 locations. The third part of the marking string is the gas group. For this example, it is 2B, which is suitable for all gases rated 2A and 2B. However, it is not suitable for gases that fall within groups 2C. The fourth part is the temperature code, which in this case is designated T5. This tells us that the relevant surface temperature of this enclosure will never exceed 100 degrees C under normal or fault conditions. Finally, we see what is called the Equipment Protection Level Marking, or EPL, which in this case is a capital G and a lowercase b. The G tells us it's suitable for a gas atmosphere, and the lowercase b tells us it's suitable for Zone 1 and Zone 2 hazardous areas. We may find additional markings on the string, including ambient temperature and ingress protection codes, letting us know the ambient temperature range and suitability of the EX equipment against solid objects and liquids. In our second example, we now have two protection concepts working together. We again have the same EX mark, letting us know the equipment is explosion protected, but now we have both DB and EB, flame-proof and increased safety combined. An example of this might be a control station in which the enclosure and connection points inside are rated EB, increased safety, and contain a small EXDB flame-proof switch inside the enclosure. In this case, the equipment is again suitable for Zone 1 and Zone 2 locations, as noted by the small b at the end of both protection concepts and the overall GB at the end of the string. In our last example, we now have the following: the EX followed by DB, flame-proof, but now we see an IA in brackets. At the end of the string, we also noticed a capital G followed by a small a within parentheses with the GB next to it. What this is telling us is that we have a flame-proof enclosure that is suitable for installation in a Zone 1 or Zone 2 environment. However, in this case, an associated apparatus for an intrinsically safe system is located within the flame-proof enclosure, providing protection downstream outside of the enclosure in a Zone 0 environment. environment. We understand this by noticing that the IA in brackets and the GA at the end of the string. In this case, the end device, which is being protected by the associated apparatus, is intrinsically safe and would be marked EXIA without any brackets, along with the gas group, temperature code, ambient temperature, and the GA equipment protection level marking. Marking strings can be confusing, but if we follow the basic premise of realizing a universal format for marking of EX equipment, we can now decipher almost any EX marking string we come across. Different world markets will require additional information on EX equipment labels, including certificate numbers and country-specific markings such as ATEX. However, now we can understand from an EX perspective whether or not a particular piece of equipment suits that environment. For those of you who want to learn more, feel free to visit academy.bartec.com, your digital learning hub. Subscribe and enjoy our learning offering in explosion protection awareness and competency. Follow us on LinkedIn, subscribe to our YouTube channel, and visit bartec.com. Reach out to me and I will personally answer your questions. Thank you for joining us today on this exploration of marking strings, and I hope you have enjoyed our videos. In the next video, you will learn how to identify competency roles, responsibilities, and requirements in explosion protection according to the IEC 60079-14, 17, and the new 44 standards.
If you want to go beyond explosion protection awareness to reach a higher level of competency and compliance, please visit our Academy website. Email at academy@bartec.com, call us at 281-214-8542, or reach out to any of our partners and BARTEC offices worldwide. It would be our pleasure to send you the brochure and information about our digital and in-person explosion protection professional competency certification program. You will receive a BARTEC Academy EXPP certificate and have the option to obtain your IEC EX certification of personnel competency for you and your whole team.